All right, now we're going to look at condensing some logarithms, which means I take a bunch of logarithms and smush them together to make one logarithm. Rule of my answer is that I want to have just one logarithm and that's it, with everything else combined within it. So I'm going to use the same properties of logarithms that we just used, the product property, quotient property, power property. Difference is when I'm condensing, I go with the power property first, then the quotient or product property next. So for example, 5 log x minus 4 log y, and I'm asked to condense it. I will start with the power property. I see this number 5 here in the front, that's going to become an exponent. I see the 4 in the front, that's going to become an exponent as well. So I'll rewrite this as the log x, or log of x to the 5th minus the log of y to the 4th. Then I'll use the quotient property because I'm subtracting the two logarithms. So this is going to become one logarithmic expression, the log of a quotient, the log of x to the 5th divided by y to the 4th. That'd be my final expression, condensed and ready to go. Another slightly more difficult one next. The ln, or natural log of 40, minus 2 times the ln of y minus the ln of x. So we could use the power property first, take that 2, sneak it right there. It's the only one to worry about. So I have the ln of 40 minus the ln of y squared minus the ln of x. Now because I'm subtracting, I'm going to use the quotient property again. Now what happens here is I'm subtracting two things. Both of these expressions are going to end up in the denominator of my final expression. 40 is going to go on the top, and then y squared and x are both going to go in the denominator like so. You might be wondering, well, if I'm subtracting this and subtracting this, does the x go underneath y squared and the y squared underneath 40? No need to do that. Here's what ends up happening. I've got the ln of 40 over xy squared because one way to think about this would be I'm taking the ln of 40 minus, in parentheses, the ln of y squared plus the ln of x. You notice what I did there is I factored out a -1 for both of those expressions and left them now as positive. So if I think about it this way, the ln of y squared plus the ln of x, well, that's using the product property. It's x times y squared. I'm subtracting that, so whatever comes after this, this expression is going to end up in the denominator, in the quotient. Okay? Now, there's another way that I could think about this even more. I could go way back to the beginning, and when I apply the power property, what I could do is, in fact, I'll just rewrite down here. ln of 40 minus 2 ln of y minus the ln of x. What I could do is when I use the power property, I could take the negative sign with it. Throw that up there. I could take this negative sign and put it up there as well. So what that would give me is the ln of 40 plus the ln of y to the -2nd plus the ln of x to the -1st. Okay, see what's going on here? So then I use the product property, add them all together, have the ln of 40 x to the -1st, y to the -2nd. I just changed the order because I like to have them in alphabetical order. Then I look at this expression and I notice these negative exponents, which I don't really care for. So I'm going to make those exponents positive by moving them to the denominator, x to the 1st, y to the +2nd. So notice I end up with the exact same expression that I had right here. The ln of 40 over xy squared. Just a different way of thinking about it. Still works out. Still is condensing logarithmic expressions. So good luck with that.